these equations that are shown on page 2 are for a stiff circuit. And what that means is I have to test my circuit for stiffness. And the circuit for stiffness is this. Write this down. Write this down. Where are you going to write it down? Write it down right beside the top line. Stiff voltage divider circuit analysis is HFE times RE greater than 10 times R2. Write that down right here at the top of page 2. Stiff voltage divider circuit analysis. What is the analysis, or what is the criteria? You're going to test your circuit for stiffness by saying, is HFE times RE greater than 10 times R2? Where is the 10 times R2? This is the R2 value. Remember, back on page 13, when I was analyzing this circuit, I said RL 10 times R2. So this concept of 10 times R2 for stiffness applies to the transistor circuit as well. And this is my test. Is this resistance, equivalent resistance, greater than 10 times R2 or not? So we're going to do this now. And then, if that is the case, I can use the equations that are on page 2. So let's do an example so that all of this makes sense. Go to page 3 now. And I'm going to put some numbers to this circuit and see if it is stiff or not. Okay? R1, 18K. I'm on page 3, everyone. R2, 4.7K. RC, 3.3K. RE, 1.2K. HFE, how much? 150. And VCC is how much? 10 volts. Okay, so there's my circuit. Those are the values. I'm going to analyze this circuit, and the whole aim is to find the Q point. That's what I'm going to now try to calculate, draw my load line, find out where the Q point is. Okay, so first thing is draw the line. So let's draw the line. Let's draw the line. X-axis, VCE. Y-axis, IC. Why am I working with VCE and IC? Those are the two important values that determine whether the transistor is fully open, fully closed, or in between, right? And that's what is the most important feature of the transistor is the voltage from the collector to the emitter, this voltage here, and the current in the transistor. So let's draw the line. You've got the space on the right side there on page 3. Draw the line, show the 0. Okay. First thing, cutoff. Where's cutoff? Right here. So, cutoff is when the transistor is open. So VCE cutoff is, let's draw this. So, if the transistor is open, what do you think is going to be the voltage from the collector to the emitter? 10 volts. So let's show 10 volts here. Cutoff is where it is open. Next, saturation. saturation. Saturation is when the transistor is fully closed. So that's the other point right here. Let's calculate that. IC sat. Supposing that I was to replace my transistor with a closed switch. What do I have? 10 volts, 3.3K, and 1.2K. Now I also have the 1.2K in the circuit. So IC sat is VCC divided by RC plus RE. Everybody see that? For the saturation value here, where my VCE value is 0 because the transistor is closed now. So, how much? 10 over what? 3.3K plus 1.2K, which is what? 2.2 milliamps. Where do I show it on the graph? Right there, 2.2 milliamps. So I found my extreme points, which are the cutoff and saturation. Now I'm going to do the analysis for these values, 18K, 4.7K, 3.3, and 1.2, and identify where the Q point is. Is it here, here, or here? Let's find out. Okay, so the first thing I do with the voltage divider circuit is to test it for stiffness. If it is stiff, then I can use the equations on page 2. So let's test it for stiffness. What is the stiffness test? Right here. Is HFE times RE greater than 10 times R2?